Yeah, good morning. Welcome to this session. So this session we'll try solve a question on a resolution. With the help of the resolution, we'll find a resultant of a coplanar concurrent force system. Okay, let us see how we solve this question. So the question says calculate the resultant of the coplanar concurrent force system shown in the figure below. Okay, so if you observe here, there is 175 Newton given with the 20-degree with respect to x-axis. Then 150 Newton given with a slope of 3 vertical, 4 horizontal. Okay, then there is another force 125 Newtons, 40-degree with respect to vertical. Okay, yeah, so how do you solve this question? Okay, so first you resolve the given forces into the rectangular components. Okay, so let us try write the components first. Okay, so first I'll try draw the components in the diagram itself. So this is its x component and y component. Okay, so x component is 175 cos 20, y component is 175 sin 20. Okay, now let us resolve the other force. Say 125. You see, this is x component and this is y component. So this is 125 sin 40. This is 125 cos 40. So if you recall the resolution of a force into components, the component towards the angle is always cos. Okay, the component away from the angle is always sine. Okay, so that if you write, so these are the components. Now to resolve 150, you need to calculate the angle here. Okay, so the given slope is like this. I just elaborate that. So this is the slope given. This 3 vertical, 4 horizontal. So let us say this is theta. So from the trigonometric function tan theta, opposite side 3, adjacent side 4. Okay, take the ratio. Now theta is tan inverse 3 by 4. So this gives you the angle of 150 with respect to horizontal. You see, with respect to horizontal. Okay, so the angle works out to be 36.9 degree. Okay, so now let us write the components. Yeah, so its x component is this much and y component. So this is now 150. So it is towards the angle. I shall write cos. Okay, 36.9 degree. This is 150 sine 36.9 degree. Okay, now let us tabulate these components for a regular easy working. Okay, so I'll try write the force first and then its x component, then its y component. Okay, so tabulating the forces and their components. So let us write 175, the first force. Okay, its x component is 175 cos 20. Okay, the value works out to be 164.5 Newton. Okay, similarly, its y component. See 175 sine 20. So which works out to be 59.9 Newton. As both are towards the positive directions, positive x-axis and positive y-axis, we represent them by positive sign. Okay. Now second force, let us take 125. You may choose any of the forces. Okay. Need not be in the same order as I consider. So now the x component, you see this much. So 125 sine 40. So the value works out to be 80.4. But you see the direction, it is towards negative x-axis. So you shall write minus. Okay. Now 125 y component. See this one. 125 cos 40. And the direction you see is also towards minus direction, negative direction. Okay. So this works out to minus 95.8 Newton. Okay. Next, going for 150 Newton. Okay. The x component is 150 cos 36.9 degree. So which is towards negative x-axis. So write minus, and the value is minus 120 Newton. I am rounding off to first decimal place. So you may observe that. And y component is towards positive y direction. So it is 150 sine 36.9 degree. So which is coming out to be 90.1 Newton. Okay. So this is how we tabulate whatever may be the number of forces. We go like this. Okay. So once you found all the components, now you just find summation. Okay. So add all these forces, we'll have sum of x components. So which is coming out to be minus 35.9 Newton. Similarly, y components summation. So which works out to be 54.2 Newton. Okay. Yeah. Now, once you find this now summation, okay, this is sigma x forces and sigma y forces. Now you plot them. Okay. So you see x forces is negative, means, for example, if I consider the x and y axis, see, yeah. So now plot x forces will plot. So negative value. So this is towards negative x axis. Okay. Value is 35.9 Newton. Whereas y value is positive, means positive y axis. Okay. So this is towards positive y axis. 54.2. You see, I have changed the length of the arrow. This is lesser in length, this is more in length. Reason is lesser value and more value than this 35.9. Okay. Now the resultant is nothing but just close this rectangle, this diagonal from this point, from the origin, the diagonal is the resultant value. Okay, so that is graphical. How do you find analytically? Okay, so resultant is equal to square root of sum of x forces whole square, sum of y forces whole square. So which is square root of sum of x forces is 35.9 whole square. So I'm not taking negative sign, you see, because we have already mentioned it in the negative direction. So you don't need negative sign. Even if you consider the negative sign, because of the square, okay, the value will not change. Sum of y forces square, 54.2 whole square. So this works out to be 65 newtons. So that is the resultant magnitude. Okay, and that's not enough. You need to say the direction also. So let us take this as alpha. Okay, with respect to x-axis, what is the angle made by the resultant? So if you see the trigonometric quantity tan alpha, so this opposite side, nothing but this dimension. This side is equal to this side, which is sigma fy value divided by sigma fx value. So if you substitute them, okay, I'll do it here itself. So it is 54.2 divided by 35.9. So alpha is going to be tan inverse of this number. So which is 56.5 degree. So this is the direction. Okay. So the magnitude and the direction. Okay. So this is how you shall solve for the resultant of a coplanar concurrent force system with the help of rectangular components of the given forces. Okay, yeah, thank you. We'll come back with the next problem.